Okay, this is Unit 6, Video 6, the heating curve. So we've learned how to calculate phase changes, and we've learned how to use specific heat to calculate maybe the change in temperature that's occurring if we put in a certain amount of energy to raise or lower the temperature of a mass. So let's look at a chart on the board, or a graph on the board. If we're going to maybe take water, for example, and go through all the different phase changes of water. We know water goes from the solid to the liquid to the gas state. It goes in through all three states of matter. We know water can go below 0 degrees Celsius. We know 0 is its freezing point. It's also its melting point. We also know that once we reach 100 degrees Celsius, we've entered the boiling point. So we know we can phase change into the gas phase. So let's say that maybe we start at a temperature, low down here, maybe 25 degrees, negative 25 degrees Celsius. Okay, well, in order to get water to melt, I have to put in energy. Okay, and I'm going to put in energy by changing the temperature. So we're going to change the temperature from negative 25 to 0 degrees Celsius. So now we've heated and put in enough energy till we've reached 0 degrees Celsius. Once we've reached 0 degrees Celsius, the temperature is no longer changing. It's going to stay constant. So remember here's the heat added, here's the temperature. Okay, so we're not, as we go up, we're changing temperature. But if we go across, we're adding heat, but we're not changing the temperature. So here, once we've reached the end point here, now we're in the liquid phase, which here we also are in the solid phase still. So we've got the solid at 0 degrees Celsius, and we've got a liquid at 0 degrees Celsius. Okay, then if we want to take it out of the liquid phase, we've got to heat it again. So we've got to add heat. So if we add heat until we reach the boiling point of water, which we know is 100 degrees Celsius, what happens when we reach 100 degrees Celsius if we reach the boiling point? So now we're going to phase change. So we're not going to change the temperature. We're just going to change how much heat was added. So we're going to flatline, because all we're doing is changing the heat added. The temperature is not changing. So here we're still in the liquid phase. So we've got liquid water at 100 degrees Celsius, but we've also got liquid steam at 100 degrees Celsius. So once everything has, not liquid steam, I'm sorry, it's just steam. We've got steam at 100 degrees Celsius. Once everything has converted over into steam, then we can take the steam and we can heat the steam to however high up we go. Maybe we go to 125 degrees. Okay, so what these different pieces mean in the heating curve is we can place the two calculations, one for phase changing and one for calculating specific heat. Okay, so here, when we're changing temperature, okay, this is going to be related to this one, and it's going to be related to this one. We're going to use Q equals SM delta T. Okay, but really when we do heating curves, we more so don't deal with specific heat. We're going to deal with heat capacity. So heat capacity tends to be, or is in moles, so you're going to really see it as Q equals C times N times delta T. Okay, and the C just represents the heat capacity. Okay, so you just need to make sure your units are matching. So here, we've got a change in temperature. So we started at an initial temperature and we ended at a final temperature. That's how we know we're using a specific heat calculation. Okay, now here, notice we flatlined. So temperature is not increasing. Okay, well, phase changes, we're not changing any temperature. So if we're not changing any temperature, we know we can use the phase change equation. So the phase change equation is Q, and for here, we're at 0 degrees Celsius, so we're melting. So this would be the Q of fusion equals the number of moles times my delta H of fusion value because I'm melting. Okay, so you have to make sure you're using your fusion value. So that would be for here. Okay, then we're going to still use our Q equals Cn times delta T. You just need to make sure that you're using your C of the liquid because we're not in the solid state anymore. We're not in the gas state. We're in the liquid state here. Okay, then when we come up here, we're flatlining again. When we flatline, we're phase changing. So here, we're going to use our phase change equation, but instead of it being the Q of fusion, now we're entering into the vapor state. So this is going to be the Q of vaporization equals the number of moles times my delta H of fusion value. Okay, vaporization value. Once I've calculated this, so I've gone to the end here, I've now reached everything is in the steam state, then we can raise the temperature of our steam. So when we're looking at heating curves, we need to make sure that when we're changing temperature, so when we've got slope forming on the graph, that means that we're going to use specific heat calculations or heat capacity. When we're flatlining, we're not changing temperature, so we're going to use our phase change equation.